Welcome to Multi-Electro.
Today I'm going to show you how to make a 100-volt electricity generator using 4 magnets, a 12-volt DC motor, and a copper coil. First, we will place a magnet on a wooden board, mark its outline carefully, and then cut out a square piece according to the marked shape. Now we will take the 12-volt DC motor and choose a drill bit that matches the size of its shaft. Then drill a hole in the center of the wooden piece. Now we will fix this wooden piece onto the motor shaft and apply glue to ensure it is securely and firmly attached. Now we will take another piece of wood and fix the motor onto it using glue, making sure it is firmly secured in place. Now we will fix the magnets onto the wooden piece, arranging them in an alternating order, one negative pole next to a positive pole, until all 4 magnets are securely attached in this sequence. Now, carefully apply a strong adhesive to each of the 4 magnets before placing them onto the wooden piece. Make sure the glue is spread evenly on the surface of every magnet to ensure a secure bond. Press each magnet firmly into position in the alternating pole arrangement, and allow sufficient time for the glue to dry completely so the magnets remain stable during rotation. Now, to make the magnets even stronger and more secure, we will wrap thread tightly around them. Carefully wind the thread around all the magnets and the wooden piece. Making sure it holds them firmly in place. This extra support will prevent the magnets from moving or shifting during high-speed rotation. After wrapping the thread properly, apply glue over the thread to lock it in position. Spread the glue evenly so it soaks into the thread and hardens after drying. Allow enough time for the glue to fully cure, ensuring the magnets are completely secure and stable. Now we will take the coil from a 440-volt magnetic contactor and carefully position it close to the rotating magnets. Place the coil near the magnet assembly, ensuring there is a small and safe gap between them. Slowly rotate the wooden piece by hand to check that after turning the magnets do not touch the coil at any point. This clearance is very important to prevent friction or damage during operation. Once proper alignment and spacing are confirmed, firmly fix the coil in place using strong adhesive. Apply glue evenly and allow it to dry completely to ensure a stable and secure installation. Now we will connect one 12-volt wire to the motor and leave the other wire disconnected for the moment. This allows us to test the setup safely before completing the full connection. After attaching the first wire securely, we will briefly power the motor to check whether it runs smoothly and whether the rotating magnets move properly without vibration or contact with the coil. We will then connect the second 12-volt wire to complete the circuit and proceed with full operation. Now we will connect the voltmeter to the two wires coming from the coil. Attach one probe to one wire and the second probe to the other wire, ensuring the connections are secure and stable. After connecting, we can monitor the voltage reading while the motor rotates the magnets. Before operating this generator, it is very important to follow proper safety precautions. Always work in a dry and clean area to avoid electrical hazards. Ensure all connections are properly insulated and secured to prevent short circuits. Do not touch exposed wires while the system is running, especially when higher voltage is being generated. Use protective gloves and safety glasses during assembly and testing. Keep loose clothing and hands away from the rotating motor and magnets. If you notice overheating, unusual noise, or vibration, immediately turn off the power supply. Safety should always be your first priority when working with electricity and rotating equipment. As you can see, the generator is now producing around 95 volts. This shows that the setup is working properly and the magnetic rotation is successfully generating electricity in the coil. The voltage may vary slightly depending on the motor speed and alignment, but reaching 95 volts confirms that the system is operating efficiently. If you found this video helpful, don't forget to like, share, and subscribe for more projects like this. When we connect and disconnect the motor wire, you can see that the voltage reading goes up and down. This happens because the motor speed changes as the connection becomes loose or stable. When we secure the wire firmly in place, the motor runs more smoothly and consistently, which can slightly increase the voltage output and make the reading more stable. That brings us to the end of this project. In this video, we built a simple electricity generator step by step using basic materials and demonstrated how it can produce around 100 volts. This shows how magnetic rotation and copper coil can generate useful electrical output. I hope you clearly understood each step of the process and how the system works. Always remember to follow safety precautions while working with electrical components. Keep experimenting, keep learning, and keep improving your skills. Thank you for watching, and I'll see you in the next project with another practical idea.
Thanks for watching. See you in the next video.